sure that I open up the virtual room for any questions that anyone might have. I know a few have been posted in the chat, and I thank you all, the audience, for your engagement with that. And I think they've been answered, the ones that were posted in the chat. So if there are there any other questions you have for any of our presenters? If you'd like to unmute and ask, feel free to do so. Because I won't read through the questions here since they've been answered, the ones in the chat. But if anyone else has a question for any of our presenters, by all means, feel free to unmute.
Hi, it's Amy McKenna. Garrett, I just wanted to ask a follow-up question. Thank you for explaining the safety hazards. Can you talk a little bit about PPE to help protect you from being injured during your experiments?
Yeah, so there's kind of two sets of PPE because you need to essentially different protocols for the furnace and the magnet. For the furnace, it's pretty straightforward. We have like these really heavy duty heat gloves that we have to wear anytime we're even close to the furnace because the convective heating around it can get up to like 300 or 400 degrees. And then we need to wear, like when we're with the furnace and when we're preparing a flux growth, when we're dealing with an open flame, we need to also wear like I don't know what you call it, kind of like a blanket coat that's largely fireproofed. And interestingly enough, I guess for the magnet, you kind of have to do like it is PPE, but it's kind of like reductionist PPE, where you have to be really vigilant about any like metal object on your person, and kind of just remove it because you can't have any ferromagnetic object within the magnet when it's running at high field within like 10 feet, or it can potentially get sucked into the magnet.
Yes.
Hi, yeah, I have a question for Jasmine, actually. So you mentioned doing NMR, using NMR for thermometry, which I think is really cool, but I don't know much about NMR. So for someone like me, can you explain how that could be used as a thermometer?
Yeah, so basically, when I was explaining the Kringa relation, when you reduce those two expressions down to basically you're combining all the constants from those two equations, and the only ones that aren't constant are T1T. So you get T1T equals a constant. And then using that, you use the T1 for whatever nucleus you're using for that temperature, and you use that with the constant to estimate, not estimate, but it gives you the temperature because T1T is a constant. I don't know if you want further explanation than that or if that was good enough.
Yeah, thank you.
Thank you.
Thank you, Jasmine. Final call for any last minute questions or comments for our students.